Hi, I'm David, this is Narek, we're both software engineers at Vineti, and we're here today to talk about test-driven development with Jest. Before we start, how many people in the room actually heard about TDD? How many people actually used TDD? How many people liked TDD? Okay, cool. So, I want to just give a brief explanation about what test-driven development actually is. Before we go into what it is, we should probably talk about what it isn't. TDD isn't just testing code. Because just when you have traditional unit tests in your applications, you usually just write your code at first and then try to backfill the tests for that code. TDD, as a philosophy, believes in doing it the other way around. So you always implement your tests first. You think about what your functional interface will look like. You think about what that function will do. You're essentially translating the requirements for your code into tests before you even start implementing your function. It all goes around a certain cycle, which is called the red-green refactor cycle. Red is the state in which you implement your test before you start writing your production code. That test fails, well, naturally, because there is no code yet. That's why it's called the red cycle. After that, you implement the production code for your test. Your test becomes green because it passes. And after that, you refactor. So you basically start cleaning up your code because maybe you did it in a messy way in the first place. And basically, you're safe because you will know if your refactor will break anything. So how many people in the room know Uncle Bob, Robert C. Martin? He's one of the very famous people in enterprise software development, has a lot of amazing books on object-oriented design. So these are the 3 laws of test-driven development by Uncle Bob, which basically encapsulate the basic concepts of test-driven development. You are not allowed to write any production code unless it's to make a failing unit test pass, meaning the green stage. So you have a failing test, you write code for it. You are not allowed to write any more of a unit test than is sufficient to fail. Meaning that generally when you're doing TDD, you're doing everything in really small increments. So you take a basic piece of functionality, you turn it into a test, and then you write the code for that functionality. You're not allowed to write any more production code than is sufficient to pass the one failing unit test. So at the point when you made the test pass, you should not continue coding. You should think about the next test. The key benefits, from a purely developer's perspective, it structures your code in a way, because you're thinking about how would you structure your code so the tests are small and concise, how to do it easier for you to test your code. It keeps you focused because essentially you just translate requirements into the specs and then you just implement the code for those requirements. On the other side, test-driven development assumes that you will have full unit test coverage on your code base. And those tests will serve as documentation for your code. So whenever another software engineer joins the company or just starts working on a piece of code he never worked on, he will know both what the code does, because he just can read the test for that code, and he will know if his changes will break anything. So yeah, the full test coverage allows you to make changes without fear. Literally all the time in enterprise development, if you don't have any kind of unit testing, usually, it's very probable that your changes somewhere here will break something else. Key misconceptions: I can always write tests later. That's a lie. That's basically a developer lying to himself. That's the same thing like when we say that some code is temporary. It's never temporary, it will stay there forever. And this is too time consuming. I have a deadline to deliver. Well, sure, you can skip writing the tests and just write your code, but it's very probable that someone else will break it and then you will have to fix it, and then someone else will break it again and you will have to fix it again and again and again. When you have good test coverage, these issues are mostly resolved, but not completely. And it's not like you need to test everything. You don't have to test third-party libraries or built-in language functionality. You have to operate under the assumption that those parts already work and already covered with tests. You don't have to test your own code over and over again. So if you have a certain class whose methods are tested, you don't have to test in different class that just uses that class. You don't have to test styling if it's on the UI. Some people actually do test CSS. I'm not sure how. We don't do that at Vineti, so this one is arguable. And instead of testing libraries or third-party REST APIs, you can just test your integrations with them. So naturally, unit tests are not enough. Even if you do it test-driven, it's very likely that they will catch in like 60 to 70% of the errors. Naturally, that's why people have integration tests, because unit tests are just checking individual logical components of your code base. They will not be checking like workflows in your applications or how all those logical components tie in together. That's why people do integration tests. So at Vineti, the agile practice that we're using is called extreme programming. It's a very interesting agile practice, but like from an engineer's perspectives, the two things that stand out to me are test-driven development and pair programming. Pair programming is the process when two engineers are working on the same machine. So two separate monitors, two separate keyboards, two separate mice. However, they're working on a similar task, on the same task, on the same machine. The way we combine test-driven development with pair programming is one person writes a test, the other person writes the code, and then they switch. What this allows for is that the tests are even less biased in this scenario, because the person that's implementing the test is not the same person that's implementing the code. So he will not be thinking about the test from the perspective of how do I fit this into the code I'm going to write. He'll be just thinking it from the perspective of the test. So this is probably the point I will be handing over to Narek, which will show a more concrete example. We'll be going over using Jest, a React UI from unit testing library.
Okay, so now let's continue talking about Jest. Jest, like a few words about Jest. Jest is a framework developed by Facebook, and it's actually based on Jasmine. Jasmine is another testing framework, and Jest works like great with React. And actually, the main reason it works great with React is that both of them are developed at Facebook. And if you look at the official Jest documentation, all the examples and basically the whole documentation is filled with React examples. And another thing we are going to talk about Jest is the snapshot testing that Jest has, and I don't know whether Jest was the first testing framework that introduced that, but we are going to talk about that. So we're going to see a couple of Jest examples. One of them is testing just regular helper functions or any functions, and testing React components. And we are also going to talk about Jest mocks, which to me is my favorite part of Jest. Let's now talk about like Enzyme. Enzyme is a testing utility which is a helper library for React, and it's like if you're using Jest, the probability that you're going to use Enzyme is very high. Enzyme is developed by Airbnb, and it makes it easier to assert, manipulate, and traverse your React component's output. So you mount your React component using Enzyme, and Enzyme provides very powerful APIs to that. We will see examples. Enzyme basically provides three kind of renderers, one of like render, shallow, and mount. Let's talk about the difference. Render does not do the lifecycle methods. It renders the children, but the only downside it provides less API. So Enzyme, the powerful APIs of Enzyme are not accessible to you. Shallow does not render the children. It's isolated, and you know for sure that, for example, if a shallow render a component that and it throws an error, you know for sure that the error thrown is coming from that component and not the children component. And mount basically is almost like the React DOM.render. It goes through all lifecycle methods and it renders all the tree, rendering all the children of the component. Okay, now let's see some examples. Is the code visible for everyone? Okay, so let's say
zoom in a little bit.
Zoom in. Okay.
Is this okay? Yeah. Okay.
Okay, now let's see examples of testing like regular, let's say, helper functions. We have a sort function that we want to test, and basically we have, we'll see the red-green refactor cycle here. So we have an array which is like just random numbers we put in, and we are calling the function and giving the argument to that function, our sort function which we imported from our own file.
But it doesn't exist yet.
Yeah.
So at this point, we're just thinking about the interface of the function.
Yeah. So for the red phase, we are just exporting like an empty function, because if the function is not exported and we call it, it obviously will throw an error. Okay. So we are expecting the result to be equal, and we are sorting manually in the test file, assuming, as Dave talked about, we do not like test already built-in methods of the language. So array.sort is a built-in method that JavaScript provides. So we assume it works, and we are expecting that the result of the sorting function, our sorting function, should be equal to array.sort, like to the sorted array that we manually sort in the test. Now, okay, we have a red test because there's no code like implemented for it. Now let's go to the green cycle. So the green cycle, we are, this is a very like simple example. We are just implementing a very simple bubble sort for it, and so we make the test pass, we make the test green. Okay, so then comes the refactor cycle, and we are using Lodash, which we assume works like better. We assume it works better than like JavaScript, not JavaScript, a bubble sort. So we're refactoring everything using Lodash's sort by.
So for the green stage in this example, we intentionally wrote bad code. Please don't do that.
Yeah.
But we did that just to show the refactor stage.
Because you have a refactor stage, you don't necessarily have to write bad code, assuming that you'll like have time to refactor that. Like you can write code, but a good code, but the main point is that you have to have a refactorment cycle on which you'll go over your code you wrote. Okay, now then we add a descending order test, which almost does the same thing but in reverse, and we add the reverse functionality for it. So we write the test for the reverse, the descending order. It fails because our function here in the refactor, after the refactor cycle, does not have a descending order like sorting. Okay, then we make the like that descending order sorting test pass by adding if the order is equal descending, return the sort by, and reverse it. Okay, then we add another test which says that when the order is not given as an argument to the sort function, it takes descending by default. Okay, now let's move on to testing React components. We have a couple of examples. Let's start with testing a stateless component. By stateless component, we mean like it just doesn't have a state, and just basically a basic component that takes an n as a props and renders in an h1 tag. And the test of that component should look like this. Remember we talked about shallow from Enzyme. We are importing it, and our component equals shallow. We are giving the component that it should render in the shallow function. So before each is a method that comes with Jest. It's basically it gets a callback at runs just calls the callback before running every single unit test. So by saying every single test unit, we mean like the test. That test is again a function that comes with Jest. Okay, so there's a very basic like test file. It has two tests. It tests that the component has one h1 tag, renders one h1 tag, and because we mounted the component using giving n as 1 in the props, we assume that the component.text should be equal to 1 as a string, because we know that the component should get an n and render that n as text. Okay, so we talked about the APIs that Enzyme provides. One of them is find. Find is a very powerful tool. Function. It basically finds anything that you give it as an argument on your mounted component. We'll see more examples of using mount later. Now let's see the stateful component. Let's look at the test first, because we again said that the tests need to be implemented before implementing the code. We have almost the same thing. We remember we talked about find in the previous file. Find, besides getting a query selector like a DOM API query selector, it can also get a class, React class, and it will return the instances of that class it finds in the component. So we know that the component that's called parent should contain one child component. Now we go to the component itself, we implement it, and we say it returns one child component. Okay. Okay, so we were talking about the test, and then we have another test which checks that the component renders one button. Let's skip over it, and okay, now let's test we can also test that the component itself, because it's a stateful component, gets the correct initial state. That's something we might sometimes want to test, and we are Enzyme also provides a function .state, which returns the state of the stateful component, and we're saying that the state should be equal n is 0 in the initial state, and we go to the component itself and we implement it to make the test pass. Now let's actually test the functionality of the component. We knew that the component renders one button, and we're getting the button in the before each, and we're saying when clicking on the button, it updates the state. Okay, we are saying we get the old state, we simulate the click event on the button, and we're saying the new state's n should be one more than the old state's n. And we also want to check that the child component gets the n, gets the correct prop that comes from the parent component state. Okay, so now, some notes on Jest. Jest already comes packed with Create React App, and there's one thing you might want to configure for making Enzyme work, and for that you use the setup test.js file. This is a file that Jest is automatically going to look before running the test. If you do not use this file, you'll have to eject from Create React App and configure Jest in that way. This is something that you want to be careful of. Do you have something to add? Okay, snapshot testing. So snapshot testing is, we talked about that Jest introduced it, and the basic idea of snapshot testing is you make let's say you want to test a pen. You make an ideal pen that you know it works because you can manually test it and you see that it can write and stuff like that. You make a picture of the ideal pen. Then after that, whenever you're making a new pen, you compare the new pens to the picture of the ideal pen you made previously. Okay? There are some benefits. Snapshot testing has some benefits. It's easy to test for components. We'll see the example. It has higher test coverage, but only for rendering. It doesn't test functionality. Again, we'll see that. We write less test cases with snapshot testing. There is actually just one snapshot test, one test case is enough. and it's easier to backfill tests. If you get lazy and don't write tests for your component at this time, you can easily backfill this, the test coverage with snapshot testing.
Before Narek shows an example, snapshot testing in general is a reason for arguing in our office. We can argue about it for hours and hours and hours. The reason being, if you notice, it's actually not very test-driven development. Because, as Narek mentioned, it's only a single test. Essentially, when he shows you the example, what it does, it takes the dump of the output of your component's render after you write the component, and then whenever you run the test, it just compares the output with the old output. Hence the metaphor about the ideal pen and just comparing pens to the pictures of the ideal pen.
So yeah, it breaks the red-green refactor cycle because you do not have a red cycle. Because if there is not, if the code of the component is not implemented, what are you snapshotting, like to make it the ideal snapshot that in the future your component should look like? Okay, let's go to like a snapshot test and see what it looks like. We want to snapshot test the, I think, the parent component. Okay, with Enzyme previously we tested, like we had two test cases. We said that the snapshot test renders one child component, then it renders one button. Okay, so we can combine all those and make one snapshot test. We can say the parent component matches the snapshot, and we're just mounting the snapshot and expecting the component to match the snapshot. To match snapshot is again something that comes with Jest. It's an API that Jest provides, and whenever we run the test, it's going to return, like make a snapshot .snap file which contains the ideal picture of our component. So it's going to look like a parent component. It renders one child component. The child component itself renders one H1 tag, and so on. Okay. And this is a good place to see the difference between mount and shallow. We mounted the parent component, then in the other test we shallowed the parent component. The difference is that in mount, the H1 in the child component got rendered because it also renders the children. But when we were doing shallow, it didn't. It just said that a child component should exist in this place. And what does the child component render? We don't care about that for now.
So this is a small component, so the snapshot is naturally small. The problem is that when you have larger components, the snapshot looks like this. And then when you're running the tests, it shows you the differences, and you can't really make anything out of it unless you read really, really carefully. And engineers are usually lazy, so what people generally do is just they update the snapshot and they don't even notice that they broke functionality.
Yeah, let's see it in the practice. We run the snapshot test, they all pass. And let's actually change something in our component. I think we were testing the stateful component. Okay, so let's add one, let's say p tag saying hello, and let's run the test again. The test failed because, and we see a diff of the, between the current rendering of the component, our component, and between the ideal picture of the component. We see a diff that a p tag with text of hello was added, and if we press U, it will update the snapshots. Now the problem comes here when you're snapshotting very big components. Your difference between your diff is going to be very huge, and reading through that diff is like time consuming and also not very pleasant experience. So it's very high probable that you'll just hit U and update the snapshots, and you won't get anything out of your snapshot testing. Yeah, but another pitfall of the snapshot testing is that it doesn't cover the logical functionality. It just tests the rendering of your components. Okay, and let's revise some key benefits that Dave talked about. We said that the tests serve as documentation for your code. So let's imagine we don't know that what the sort function does, or okay, let's say that we don't know that what the stateful component does. Okay, so we can read the test file for the component itself, and we can see it's like it's almost English. We can say that the parent component renders one child component. We can just read the description of the test cases, and it's a documentation for us to know what the parent component should be doing. Okay?
It's not almost English. It's literally English.
Yeah, it's literally English. So we don't have to go into the stateful component itself to read the functionality. Okay, and another key benefit is that the full test coverage allows us to make changes without fear. Again, we saw that if I change something, a very minor thing in the components or the functions I'm testing, the tests are failing. So what that provides me is that when we are working with huge code bases, me as a developer, I'm very, very afraid to touch any code that wasn't written for me or that was written by me and it's not another person is using it. Because I don't know what the other person has done, in what scenarios they are using it, so I don't know whether I will break their stuff by changing anything in the code base. So if I have full test coverage, which is again very debatable, it's not easy to have full test. I think it's impossible to have full test, 100% test coverage. So it makes me a bit less afraid to touch the code. Okay, questions? Okay.
No questions? Sure.
Does TDD being used outside of pair programming, and is there any benefit? Could you please repeat the question?
Yeah, so the question is TDD being used outside pair programming? Of course, TDD is a practice that can work by itself. With pair programming, it's part of the extreme programming ideology. It has, you don't have to always do extreme programming or pair programming to do TDD. You can do TDD for your own side projects that you're doing alone.
Yeah, I have a question. Is there a way to, so when I snapshot test, it just creates new files for me, right? These snapshot files. Is there a way to avoid that?
So it doesn't create new snapshot files instantly. At first, it takes it and it compares the new snapshot with the old snapshot. And there's an argument, or you just press U, and then it will update the snapshot. So it doesn't update it instantly. It shows you the difference first.
Where is the snapshot?
The snapshot test is in a dash snapshots folder that Jest creates by itself, and it's putting all the snapshots there. Okay.
Does Jest provide any functionality to see the test coverage? I mean, for example, in Angular, you can run ng test coverage and get...
Yeah, we can do the following. It is, if I'm not mistaken, yarn test dash coverage. I think. It's running the test. Yeah, here we can see test coverage. Okay, so the test coverage showed that only index.js and service worker.js tests were not covered. Files were not covered because those are not our files. They come with create React app. Okay. Questions? No? So?
Okay,
We're done.